I'm here with Taylor Stein from Autodesk. He is a mechanical engineer and Autodesk evangelist in San Francisco. And he actually has been at some Hackster events previously. He's a Fusion 360 ninja, an excessive coffee drinker, and he's building a racing drone right now. So he does some cool stuff in his spare time at Autodesk Pier 9. I'll make you presenter.
Cool.
So he'll be teaching you how to build this object here today. So I'll let him take it from here, I guess.
Cool. Well, thanks everyone for attending. So in this little webinar, what I was thinking I was going to show was how to build this little desktop fan. I did make it last week, and I must say it needs a little bit of work. So it's a little noisy, but I think there's room for it to be improved. But it's a fun little project to learn how you can build a simple little 3D printed project with some simple electronics and learn Fusion 360 in the process. Yeah, so for those of you that aren't familiar with Fusion 360, I have a little, here's the website where you can get it. So you can always access Fusion 360 if you go to autodesk.com/Fusion360. For those of you that don't know what it is, it's a really cloud-enabled tool for product development, everything from conceptual design all the way through fabrication. So if you want to do any CNC work or anything like that, you can. Its main point is that it's one of the biggest features, I guess, is that it's accessible. So it's free for hobbyists and makers and any startups. So as long as you're making less than $100,000 a year off what you're doing with the software, it's free. We only have people pay once they're making over that. It runs on a Mac and a PC, and being that it's cloud-based, you can sign in on any machine and access your data sort of wherever you are. So it doesn't matter if you're at a makerspace that has desktop machines there or your own laptop, you can sort of sign in wherever and get your work. So that's a little bit on Fusion 360, and we can jump right into it. And I was telling Monica, I think it might be best for this to be sort of just like a watch and learn, and if you guys have questions, feel free to post them. And yeah, if you try to follow along click for click, sometimes you can get lost in the small details. So yeah, just a little bit of a learning session. So we can jump right into it. I'm going to kill my webcam for right now so this doesn't get too slow. So here's the fan that we're going to be making. We're going to be designing the motor. We're going to be modeling that in Fusion 360. We're going to be modeling the sort of enclosure here, and then the fan I've already modeled ahead of time, and I'm going to show you how you can take that model from online, download it, and import it into Fusion. It's a little bit more complicated than like a very introductory project for Fusion. So this is what we're going to make, and I guess I can start by giving you a quick little tour of the product. So here's Fusion 360. You'll see this is the fan design that I have open. At the top here is the toolbar. So we have these different workspaces. So if you're ever looking for a command, you really just need to ask yourself, what is it that I'm trying to accomplish? Am I trying to make a 3D model? Am I trying to do surface modeling, sheet metal, rendering, animation, and so forth? And then in each given workspace, we have a set of tools in the ribbon up here. So in the model workspace, they're categorized by really, again, what you're trying to accomplish. So are you trying to create sketches, really two-dimensional foundational geometry? Are you trying to create new geometry? So as making the initial box that we see here, cutting holes in it, all those are going to be here in the Create menu. If you're looking to modify things that you already have created, those will be here in the Modify menu. So if we're trying to make something hollow or apply a draft angle, we'll do that with these tools. And then when you want to put these parts together, you'll use some of these assemble tools. And we might use a few of these other ones, construction, inspect, some of those will jump around there, but all your tools are here at the top. On the left, we have our browser, and this is really just an organized list of everything in your Fusion 360 design. So you'll see here at the very top, this is the name of my design, Portable Fan. It has a version number, and I'll get into that in a little bit. Whenever you make a save in Fusion 360, it's automatically saving a new version for you, so you don't have to manually create different versions and have Portable Fan 2, Portable Fan Final, anything like that. And within the browser, We have our units here, so I'm working in millimeters. And this is really just folders that organize everything in the design. So I have my various parts, for example, the fan blade or the motor or the actual enclosure. And these are all what we call components inside of Fusion 360. You can think about components as actual real world parts that would move independently. So I've broken it down to 3 different components here. Sketches and bodies and so forth. And down here at the bottom, we have our timeline. So whenever you're performing a command in Fusion 360 and creating a feature, that feature will show up here in the bottom of the timeline. So it shows up in chronological order from left to right, and this means that you can roll back at any point, make a change, and roll forward. If you need to make an edit to a command, you can find the command here. Some tools will sort of join these 2 together on the left, but we break it apart so we have really just like the ingredients of your design on the left and how you went about doing it on the bottom. It seems to make sense for me at least. And don't worry, it's not going to be as complicated as my first attempt at doing this. This was really just a rough go at it, so we'll see how simple it really is. As far as navigating around the view space, I recommend that you use a mouse. So if you scroll up and down on the scroll wheel, you can zoom in or zoom out. If it feels like it's backwards, you can always go to your preferences and change that direction. If you click and hold on the scroll wheel and move the mouse around, you'll pan. It's almost like you're looking through a window. You're not orbiting, you're not zooming, you're just grabbing what's on the screen and moving it around. And then if you hold Shift and click the middle mouse button, you can then orbit around. So if I want to look at the top of the model, I can orbit to the top. I can look at the side or the front, and so forth. You can also use the view cube up here. So if I want to grab the cube, I can drag it around and look at different sides of the model. And I can also look at any of these sort of existing views. So if I want to look at the front of the model, I can click front. I can click these little triangles to rotate 90 degrees. And if I'm ever sort of lost, I can click this little house, and it'll bring me back to a nice home view of the model. And all of those navigation tools that I described are down here at the bottom. So orbit is this button down here, as well as pan and zoom. And if you don't have a mouse, sometimes a trackpad can work. On a Mac, a trackpad works really well, so I'm actually just using a trackpad now. You can use some of the multi-touch capabilities and gestures to pan and zoom and orbit, so it's pretty convenient. Cool, so let's jump right into it. I'm going to go ahead and open up a new design. So from the File menu up here, I'm going to say New Design. And before we get started, the first thing that I need to do is think about the different parts in this design. So if I think, you don't always have the finished model to look at, but when I think about making this, the various parts that I have are going to be the enclosure, the motor, and the fan blade. So each of those needs to be its own component inside of Fusion 360 in order to use the software the best. So in my blank design, I'm going to start by making a component for the motor that we're going to model. So to do that, I'm going to click this new component button right here. And I want to create an empty component. And I want to call this component, let's just call it toy motor. This is just a small DC toy motor you'll find just about anywhere. And I will click OK. And you'll see that I have this toy motor component, which is now in the hierarchy under my overall design. So when I save the design, the name will be here, and this is my component for just the motor. So what we're going to do now is use some of the simple sketch and extrude tools to model the motor. You don't have to make it incredibly detailed. I really just capture what I really need. I'm not going to model every tiny little hole. I'm just going to model really the bounding box and the features that I need on the motor. So I went ahead, sometimes you can find the dimensions online. I just grabbed the actual motor itself and some digital calipers and measured it. And you'll see these are some of the measurements that I got. So we'll be referencing this as we model the motor inside of Fusion 360. So it's a little bit hard to see from this angle, but I'm going to start by drawing the front view of this motor, what you would sort of see from the right here. And I'm going to sketch that out and start by creating this shape over here. So let's go back into Fusion. And to start, I'm going to tell the software that I want to make a new sketch. So into the Sketch menu, I'm going to choose Create Sketch, which is really like asking the software for a blank piece of paper. So I've asked for a sketch. and the software is going to ask me, where do I want to place that piece of paper? Because this is a 3D tool, it needs to know where am I, essentially what surface am I drawing on? Am I drawing on the floor, so to speak, or one of these vertical walls? It doesn't really matter. I like to keep it aligned with the view cube names as possible. So being that I'm drawing the front, in my mind, of the motor, I'm going to make sure I'm drawing on this plane, which sort of matches up with the front of the view cube. So I'll click on this plane over here, and you'll see that I can see my origin, and I have a nice clean sketch plane to draw on. If I enable the sketch grid and orbit around, you'll see sort of that I'm drawing on this plane in 3D space. Turn the grid off. So let's go ahead and start by drawing out the main shape for this motor. I'm going to start by drawing a rectangle. So to do that, under the sketch menu, I'll go to rectangle, and there's a few different ways that you can define a rectangle. You can define it by telling it the corners, 3 of the corners, or a center point and 1 of the corners. So for this one, I'm going to choose center rectangle because I want to keep everything as centered about the origin as possible. That'll make it so that any steps I have to do down the road will be as easy as possible. I don't want to draw this motor just over here for no reason. It's nice to keep things aligned to the origin. So I'm going to choose center rectangle, and if I move my mouse over here and stop, it's going to ask me to place the center point. So the center point, I want to put it on the origin, so I'm going to move my mouse to the origin until I get this blue box and it snaps to it, and I'm going to click and let go and move my mouse out here. And it's a little bit tempting here to start typing in dimensions, but what I like to teach folks is to just draw the shapes that you need on the screen, apply any constraints that you need, and then go ahead and dimension them last. So if I don't want to add any of these dimensions, I can just go ahead and move it until it looks maybe close and click. I can zoom in, and now I've drawn this rectangle, but it's not dimensioned at all. So if I look at the motor, it's a little bit hard to see from this view, but it's not rectangular. It's flat on the top, it's flat on the bottom, but these sides are curved completely all the way around. So let's go ahead and draw some arcs that represent the side of the motor. So from the sketch menu, I can find arc, and just like rectangle, there's multiple ways to define an arc. So I'm going to choose a 3-point arc, and I'm going to start by placing one end of the arc on this top line, one end on this bottom line, and I can snap it here to the side if I want. I like to be a little bit explicit about it, so I'm going to draw it intentionally wrong a little bit and then use constraints afterward to get it exactly how I want. So I'll hit escape to stop drawing any more arcs, and now I can start applying some constraints here. So I want, when I measured this, I measured the width here at 20 millimeters, really from the edge of that arc to the edge of this arc. So I know that in the software, I want this arc to just be tangent or just touch this line over here. So to do that, I'm going to choose the tangent constraint and now tell the software what 2 things I want to be tangent. So I want this arc to be tangent to this line. I also want to make sure that this arc, that these 2 points are vertical from one another. So I'll choose the vertical constraint and again pick these 2 items right here. And now if I click and drag on this corner, you'll see that as I move the box around, that arc stays with it. If I move these points around, they're staying vertical with each other, and the arc is staying tangent with the side of the box, which is just what I want. I need another arc on the left-hand side, and I don't necessarily want to repeat all those steps, so I can use a mirror feature just to mirror it across. The mirror feature does need a line to reflect it about, but I do not have a vertical line there already, so we need to draw one of those in. So I'm going to choose the line tool. It's from here in Sketch. I can choose line or hit the L hotkey. And I'm going to start it at the midpoint of this top line, and the cursor will snap to there and give me this triangle icon letting me know it's the midpoint. And I'll snap to the bottom midpoint down here, and I'll hit escape to stop drawing lines. And we'll see that I now have this line here that I can use for a mirror. So from the sketch menu, we can look for mirror. What object do I want to mirror? That's going to be this arc. What's my mirror line? That's going to be this line. And I'll hit OK. And I don't want this line to really separate this into 2 different profiles. I just want it to be there for reference. So I'm going to turn it into a construction line, which is like one of these orange lines that you see right here. So I'm going to click this line and choose normal/construction, and now it's just a reference line, but it's not interfering with my profiles. So now that I have all of the geometry drawn out and the constraints applied, I can now dimension the motor. So as I mentioned, it's 20 millimeters wide, and I jotted down here that's 15 millimeters tall. So to do that, let's go to the sketch menu and choose sketch dimension, and we'll say that this line up here is 20 millimeters, and this line over here is 15 millimeters. And now the only thing that's left is how far does this arc extend? I didn't label it here in the image, but I went ahead and grabbed my calipers and measured roughly the distance from here to here, and that came out to be about 14 millimeters. So I can dimension the distance between these and really lock in these arcs. So again, under the sketch menu, I'll choose sketch dimension, and I'll pick this point and this point, and move my mouse up here until the dimension's somewhere nice and clean, and click, and I'll type in 14. So now you'll see that all the sketch curves are black, which indicate that the sketch is fully defined. There's no more sort of wiggle room in this sketch. There's no way that I can drag this around and change its size without changing these dimensions, which I can do if I want. If the motor was actually 10 millimeters tall, I could change it to 10 and it will update, but it's 15, so we're going to leave it like that. Great. So the sketch is done, so I'm going to choose Stop Sketch, which is essentially me telling the software I'm done drawing the two-dimensional shape and I'm ready to create a 3D object out of this. If I go back to the image here, we'll see that it is about 27.5 millimeters long, and I can go ahead and do that with an Extrude command. So under the Create menu, I'll choose Extrude. The profile, that's sort of what profile do I want to extrude. That's going to be this shape. I don't need any of these corners. And it's 27.5 millimeters. So I'll type in 27.5. And now we've sort of extruded the shape out. I want to create a new body, and I'll hit OK. And now would be a good time to see here that in our toy motor component, it has its own origin, which is aligned with my sort of world origin that never moves. This origin will move with the motor if it ever moves around. It's comprised of this one body, which is a solid body, and that body was created through this one sketch right here. So that's sort of the hierarchy within a component. So I'm not done modeling the motor. We can see over here, it really doesn't extend all the way to this back piece over here. So I need to sort of remove all of this, and if you look at the back of the motor, it's really just a circle with a line on the bottom for a flat side, and I have those dimensions jotted down over here, so let's go ahead and model that. I'm going to go ahead and create a new sketch, and I don't have to sketch on one of these planes. I can sketch on an existing face of the model, so I'm going to choose this back face over here. Now that I'm sketching on that plane, I can go ahead and draw out the shapes that I want. So I'm going to start by drawing a center diameter circle, and I'm going to draw a horizontal line that flattens the bottom there. And I can now use my dimensions to size this up. So I measured it, and this circle here is about 9.8 millimeters in diameter. And the distance between the center point and this line comes out to about 3 millimeters. So now we have this shape here. And what I'm going to do is grab this geometry as well as this and push it back a little bit. So let's go ahead and choose Stop Sketch. I will choose Extrude, and let's grab these two profiles. And now I want to cut in a little bit. I actually did not jot down how much this was, but we can guess. Should be just fine. So let's go ahead and create this sort of cutout here. So if I drag it in, you'll see that the software sees that I'm cutting through an existing part, so it's going to change the operation automatically to cut, which is what I want. I don't want to add this to the motor. I really want to remove this, so that's why my operation says cut. So let's see, how about 3 millimeters? That seems right. And you'll see that this is the negative direction, so I can type in -3. And I want to perform a cut and hit OK. And lastly, there is a tiny bit of the shaft sticking out the back here. So I'm going to, again, create another sketch on now this face. And I'll draw a center diameter circle. So you'll see it's pretty repetitive. And I'll draw a circle that's centered on the origin. and this is 2 millimeters. And I can stop my sketch and now extrude this out the 1 millimeter that it sticks out. I'm just modeling this in just to make sure that I don't forget about it and have this motor butt up against something and have this get in the way. So I extruded out 1 millimeters and I want to join to the motor. This is where I don't really need the motor to be modeled perfectly. I don't need the shaft to actually rotate within the motor. I'm okay with just having one sort of block of geometry that represents the motor. So this is why the operation here is join, which will fuse all of these parts together. So I'll hit OK, and we've got the motor shaft sticking out the back, and now all that we need to do is model the front of the motor. So let's go ahead and do these last few steps a few more times. Again, I'll create a new sketch on this face, grab my circle tool, and draw a circle that is 6 millimeters in diameter. I can draw that at 6 millimeters. And I'll choose Stop Sketch. And I can now again choose Extrude, and we can extrude this out by 1.3 millimeters. And I want to perform a join. And one more feature, I can sketch on now this face, draw another circle. And this is for the shaft, so this will be 2 millimeters. And I'll now go to Create and extrude this out for the shaft, and that is 8 millimeters. It has a small little chamfer on it. I don't really need to add it, but it shows us how to use some modifiers. So here in the modifiers, I have chamfer, and I can pick this edge and just apply, how about just a fraction of a millimeter, just a small chamfer there to sort of break off the edge. And if we look at the motor one more time, these sort of edges here are not perfectly, they're not sharp, they're rounded off a little bit. So we can use the fillet command to select these sharp edges, and I don't have to hold shift, which is actually really nice. And I can select all 4 of these, and let's just apply, how about a 2 millimeter radius fillet. So now we've got our motor just about completely modeled. I'll go back to my home view, and there it is. So I'm going to go ahead and save this file. So I'll click on Save, and I'll give it a name. So let's just call this Webinar Desktop Fan. It's saving it in a project, which we'll get into a little bit later, but just know that saving into a project, which is really just like a shared sort of folder. I'll hit Save, and now we've saved the motor here. So if we go to the finished design, that's just about everything we need for the motor. What we can start doing now is working on the enclosure. So if I go back to the design that we're working on, you'll notice here that I'm currently working on the motor component, so that's why it has this little radio button checked right here. But now that I know that I want to start working on the housing for this, I don't want the housing to live in the same component as the motor. At the end of the day, they're different parts and they're different objects, so I want to keep those separate. So I need to now create a new component for the housing. So I'll go and click my New Component button. For the name, I'll call this Housing. And it's really tempting right now to hit OK and keep going. But let's see what happens when I hit OK. So what it's going to do now is, because the active component was the toy motor, it now created another component within the motor component, which is not what I want. The housing isn't really part of the motor. They're separate parts that should really be at the same level of the hierarchy. So I'm going to undo that, and let's click New Component one more time, and I'll call this Housing. And here where it says Parent Component, it says One Selected, and Toy Motor is highlighted blue. So that's the software telling me that this is the parent component, which is going to be one level up in the hierarchy. So to change that, I'll click this X and change the parent component to just the top level here. And I'll hit OK. And now, if I sort of minimize the toy motor, you'll see that I now have a housing component which is at the same level of sort of this family tree as the housing and toy motor are the same, which makes sense in my mind. And it automatically activates the housing. So now any features that I do will be for the housing. And you'll notice a few things. First, sort of the motor is grayed out because I'm telling the software I just want to work on the housing. If I wanted to work on the motor, I can hover over the motor and check the box here, and now I'm working on the motor. And you'll see that the software just shows me the features that I'm using for that component. So when I switch over and tell the software I want to work on the enclosure, I'll activate this one, and all of the features for the toy motor are hidden, which is a nice way of keeping everything nice and tidy and making it so that you don't have a really nasty long timeline. So let's go ahead and sketch out the shape for the enclosure. So to do that, I'm going to start by, again, telling Fusion I want to make a new sketch. And it's going to ask me what's the plane I want to draw on. And I'm going to draw this shape from the side. So I'm going to choose one of these vertical planes here. You'll see I'm having a little bit of a hard time selecting this plane here between the green and the blue axes. It's thinking I want to pick the front of the motor. So if I need to ever choose something that's hidden underneath my mouse or under other objects, I can left click and hold until I get this menu and let go. And then I can come in here and specify what it is I'm actually trying to pick. So I'm trying to pick the YZ plane. So now if I click that, now I'm sketching on the YZ plane. So let's zoom out a little bit, and what I'm going to do is grab just the line tool and draw out a really rough shape of what I want this housing to look like. It really doesn't have to be incredibly accurate. Let's see here. Just notice that the shaft is it in line? Okay, I think the shaft is in line. It's just a sort of an optical illusion. It looks like it's lower than the middle. So back to making the housing. I'm going to pick the line tool and let's draw out a very rough shape. And I actually realized I jumped ahead one step a little bit too much. So right now the motor is completely horizontal, and I want it to be pitched up a little bit, maybe around 20 degrees. And I want to do this before I model the housing. I don't want to model the housing sort of at an angle sloping downwards so that the motor is facing up. So let's just stop our sketch here. Go back to the motor component, and let's go ahead and start the move command. And I want to choose what it is I'm moving. So I want to move the entire motor component. So that's going to be this component. And I want to rotate it up by 20 degrees. So we'll do -20 and hit OK. And now I want to capture the position, which is really taking a snapshot of the motor's position in time. And now it will add that to my timeline. So if I go back to my very top level, now this movement of the motor is actually captured. So if I go back sort of one feature, the motor's flat. When I go forward one, it acknowledges that move command, and it's sort of that keyframe just about where I took a picture of it. And now if I look at the motor from the left side, you'll see that it is sloped up. So now let's go back to the housing, and let's go ahead and I'm going to delete this sketch by right-clicking on it and choose Delete. And let's go ahead and make a new sketch. And I want to sketch on, again, the YZ plane. And now I can draw the rough shape of the housing. So let's choose the line command. And I'm going to draw out a really rough shape. So I'm going to draw a line that's horizontal over here. I want it to go up a bit. I want it to cut across here. I want it to cut across here, back down, and then connect it over here. So that's by no means exactly how I want it to look, but the important part here is that you're just drawing the shapes that you want. And now we're going to use these constraints to actually tie it down so that it moves the way we want, and then dimension it to size everything that we like. So some simple things that I know I want. For example, I want these two lines to be the same. So I want to sort of have a flat bottom here going across. So I want this line to be vertical and the same height as this one. So I'm going to start by choosing the horizontal/vertical constraint and just clicking on this line here, which will snap it to be vertical. And if I drag it down, see that it adjusts and it's staying vertical, but I want this to be at the same level. So I'm going to now choose again, the same horizontal/vertical constraint. It will really apply whichever is closest. So in this case, I'm going to apply a horizontal constraint between these 2 points. So I'll click this point and this point. And now if I hit escape and drag on this, you'll see that they're staying sort of the same height, which is nice. Now I also know that just for looks, I want this line to be parallel to the motor. So to do that, I'm going to choose parallel and pick this line and pick one of these lines here that represents the main direction of the motor. So I'll click that. And now, no matter what I do to this line, it's going to stay vertical to that. I also want this line here to be in parallel to this face right here. To do that, I can make it parallel, or I could also make this line perpendicular to this one because it's at a 90-degree angle. So I'll choose perpendicular and choose these two lines. So now it's starting to take shape and look pretty good. I think that's all of the constraints that I need. All that I need to do now is dimension it. So to do that, again, I'll choose my dimension tool, and I want the base to be 50 millimeters long, and I can hit escape and I can sort of drag this around and move it back where I want. Sometimes it'll sort of take a shape you're not looking for. There we go. I want this to be only 10 millimeters, so I can hit the D hotkey to start the dimension tool. And let's make this 10 millimeters. If I move around, I want to have, let's see, a little bit of a gap here between this top surface and the top of the motor. I want to have some room to work with. So let's choose this line and this line of the top of the motor. And let's make that, how about 4 millimeters? And I want to also have some room back here. So let's choose this point and this end of the motor shaft. And let's see if we can try that one more time. This end of the motor and this line, and let's make that 4 millimeters. And lastly, I'd like to have a little bit of room here between the front of the motor and the front of this. So I'll choose this line and this front face of the motor, and let's make that 1 millimeter. We now just need to sort of specify the angle here. The motor is sloped up at 20 degrees, so it'd be nice if this sort of angle here complements that. So let's choose our dimension tool and pick this line and this line. We can apply an angular dimension. Let's make this 70 degrees. And now everything is black and locked in completely. If we need to make changes to these dimensions, we can always come back and edit them, but this is just sort of the starting point. So I'll go ahead and stop my sketch. And now we're ready to create the main sort of block of the housing, and then we can start splitting it into different parts and removing some of the inside so the motor will actually fit. So again, to create some geometry, I'm going to choose the extrude command, pick this profile, and let's figure out how much we want to extrude it by. So I'm extruding it just one way for now. I think about 15 would be good. So I can do that. If I wanted to see the motor, I could change my visual style to have hidden edges. Now I see how much sort of extra room I have, which looks good to me. And I don't just want to make half of the housing, I want to make it on both sides. So instead of just extruding to one side, I'll change the direction to symmetric. And I want to create a new body. So I'll hit OK. And now we sort of have this main body here for the housing. We're ready to sort of get going at it. So the first obvious thing that we need to do is we need to cut out some of this housing so that the motor can actually fit in there. Right now they're sharing the same space and it's not going to work. So to do that, let's go ahead and create a new sketch on the front face of the motor, or sorry, of the housing. And what I want to do now is I want to be able to see the motor, but it's not currently in my sketch. So this is where you can use the project tool, which will really shine in and project, for lack of a better word, geometry outside of your sketch into your sketch. It's almost like you're holding a flashlight up to something and you're projecting its shadow onto whatever plane you're sketching on. So I'm going to hide the housing body here, and we can now see the motor, but it'd be nice if we actually can reference it instead of just eyeballing it close to the edges. So from the sketch menu, we can go down to project, and I want to project this entire body, so I'll choose the body filter and click on the body. And now I've projected sort of the silhouette of the motor into my sketch. So if I were to hide the motor body, I still can reference its outline, which is nice. So now we're ready to start drawing some lines to actually cut this out. So I want to have one line that represents sort of the surface that the motor is going to sit on. So I'll choose the line tool and I'll draw a line that goes horizontal across to the other side. If I snap it there, I'll see I have that perpendicular constraint. I want to have a line that goes roughly through the middle, so I'm just going to draw it close right now, and then we can go ahead and constrain it later. So let's move it till it snaps at perpendicular, and there we go. I can apply some constraints. If I want this line to be in line with the base here, I'll choose collinear and choose this line and the bottom of the motor. And I can choose coincident to make sure that this line touches the middle point right here. Cool. So we could just about cut this all the way through. There's one part on the motor, it's a little bit hard to see, but on the opposite side of this, there's the leads that come out for the positive and negative, and they actually stand up a little bit further than the dimensions here. So I want to make sure that I have some room up here to work with, and I also want to make sure that when I create sort of this this contour here for the motor to rest in, that it can actually fit. I don't want to have no tolerance in my design and hope that everything fits, because if my printer prints something a little bit too large, maybe the motor doesn't fit in this sort of curve anymore, and now my housing doesn't shut. So let's use the offset tool to create an offset of this curve right here. So I'm just going to make an offset of 0.2 millimeters, just a small fraction of a millimeter, so that we know that this housing will actually fit. And then what I can also do is, I know that I can model it in, but for time, there are these leads that stick out of the back here, so I want to make sure that this is nice and open. So let's go ahead and draw a line that goes from, how about somewhere over here, vertical down to this point that we've offset. And I also want to make sure that I have this line going down here. Great. And now what I can do is dimension this. So let's just create a dimension here, and we'll just call that 8. And now I want to mirror this line over. So I can choose the mirror command and mirror this line about this. And I want to turn this into a construction line. So a lot of the same steps. I want to now draw one more line up here, so that when I sort of cut out these profiles, I'm not removing the top of our enclosure. So I'll draw a line that goes horizontal across here. And I'll use the dimension tool to dimension this to be 2 millimeters. And now we're ready to sort of cut out a lot of these shapes. So I'll choose Stop Sketch. I'll go back to my Extrude command. And now we're going to select this profile, and this one. And then we need to be careful that we also pick these little profiles that represent the sort of the offset that we created, so this actually fits. I'm not going to choose the bottom one here, because I want to make sure that the motor actually sits flat on that bottom surface. So now that I've picked those, we need to choose how far we extrude this back and how much we cut out. So instead of just eyeballing it and cutting enough, or kind of remembering how long the motor is, we can actually reference the motor itself. So I'll hide the housing so that we can see the back of the motor. And what I'm going to do now is I'm going to, instead of extruding a distance, I'm going to say I want to extrude to something in the scene. So I want to extrude to the back end of this shaft that sticks out. And because the shapes don't match, I'm going to switch it to this setting over here. And now it's extruding all the way to that back end of the shaft. And I don't want to create a new body. What I really want to do is cut. So I'll change my operation to cut. And I'll show my housing, and now we can see what we're cutting out. We need to be careful that we're not cutting the motor. So if I open up this Objects to Cut window here, we'll see that we're cutting both the motor and the housing, which is not what we want. So I'll uncheck the box here to make sure that we're just cutting a hole in the housing. So I'll hit OK. And now we'll see that if I hide the motor, we've sort of cut out this shape for the motor to sit in there. And we're just about done. There's a few more steps that we need to do to finish this up, but this would work pretty well. The only issue is that we have leads coming out the back of the motor at the top. There's no way to get to, so in my mind, I wanted to split this up into a 2-part housing, so sort of like a clamshell, which is the top half and the bottom half, and make it hollow on the inside for wires. I forgot to mention it, but this really, the design's just running off of power over USB, so just 5 volts DC. So for the design, I just got a iPhone USB cable and cut it in half, and then just using 2 of the leads, just the positive and negative. You don't need any of the data lines. So now what we can do is continue working on this housing just to sort of make it look a little bit better and make sure it actually functions properly. So one thing that I don't like about it right now is that it's very boxy and there's no real lines to it. So in my mind, it'd be nice if we look at the front here, if this sort of tapered out to the bottom, and if it also tapered out towards the back, so it has a little bit more of a dynamic shape. So to do that, under the Modify menu, I can choose Draft, and we can now sort of slope this around and make some slight modifications to it. So I want to sort of take these sides and slope them out. So if we think about which plane I need to slope them from, it's going to be this plane right here. And then the faces that I want to draft are going to be these two faces. And now using this manipulator, you can see that it's applying that angle from that top surface. So that edge is not really moving, it's just the angle from that edge is flaring out. So let's do 5 degrees. That seems to look nice, and I'll hit OK. But it's still pretty boxy from this side. So now we can, again, flare it out again towards the back. So again, I'll choose Modify and Draft. And the plane that I want to draft from is this one. And these are the planes I like to draft. And it remembers that I like 5 degrees for draft, so it's doing that, but it's the wrong direction. I actually want to flare it in. So let's do -5 and hit OK. So now we have a shape that looks a little bit more interesting. It's not so boxy. And we can get going. So before we get too far, I want to round off some of these edges. It's nice to do it early on before you get too far into the design. So to do that, from Modify, we'll choose Fillet. And I'm first just going to apply a small fillet to these edges, these 4 edges that sort of run around the top. And let's just add maybe not 10, how about half a millimeter, something small, maybe 1. So we've rounded those off. And now I want to add one more fillet to these sort of loops around the side. So I'll add a 1 millimeter fillet there. And now we've given this a little bit of a better rounded look. If I change my view to just shaded, we'll get a better idea of what it will look like. So we won't see the lines when it's actually made, but now it's a little bit rounder and not going to, be incredibly sharp or anything like that. So it's nice and smooth. So now that we've gone ahead and rounded them off, let's go ahead and make our first split of the model, which is going to separate the top and bottom halves of this housing. So remember I drew in this initial sketch that line at the bottom of the motor. So I can turn that sketch back on, and now I can use this line to chop this in half. So under the Modify menu, let's choose Split Body. And for the body to split, that's going to be this right here. And for the splitting tool, I'm going to pick this line. And now what we're doing is we're splitting it down this line. So if I hide the sketch, we'll see that my housing, I've now broken it down into 2 different bodies. I have a top half and a bottom half. And both of them really hold the motor like that. So what we can do now is, let's see here. Actually, I want to split that, at a different line, not at the bottom. I want to split it at the midplane here. So let's go back to my split body and we'll choose Edit Feature. And the splitting tool is actually going to be, let me move this around over here. Splitting tool is actually going to be this line. There we go. So now we have a top half and a bottom half that really sit right at the midpoint of that motor. Perfect. So now what we can do is let's just start looking at the top half only. So I'll hide the bottom and sort of look at this in section view here. I know that I want this area back here to be hollow, but the only issue is that when I use the shell command, it's going to make whatever I pick a certain wall thickness, and I don't want to remove any material here. So I need to split this into 2 different bodies and then combine them later on. So under Modify, I'll choose Split Body, and this is the body that I want to split, and this is the splitting tool. So now I've broken this down to 2 more bodies. And now what I can do is use the shell command and pick this face as well as this face and enter in a wall thickness like 2 millimeters. And now I've gone ahead and hollowed out that part of it. Now what I can do is I just want to make sure that I have room for those leads over here. So I'm going to create a sketch on this face. And I want to project in this line. So I'm going to choose my project tool and project this in. And let's just draw a line that goes from here to here. And I can make that perpendicular. Cool. And I didn't measure how big the leads were, but let's just make this 10 millimeters. Choose Stop Sketch. And now we can go ahead and use this Extrude tool to, again, cut to this surface and just remove parts from the housing. So now we've cleaned it up on one side. We can use the mirror tool to mirror it over again. So I'll choose mirror, and this is the mirror in the create menu, which is slightly different. I want to mirror that cut feature, and I want to mirror it about this vertical plane. Cool. So now I've got room on both sides. The top here is just about done. I just need to go ahead and combine them back together. So under Modify, I'll choose Combine. It doesn't matter which one is my target body or which one's my tool body. I can just combine these two parts together, and now they're sort of fused together as one part. So now we can work on the bottom half, and we need to do a similar thing over here. I want to hollow this part out but keep this all solid. So again, I'll choose Modify and Split Body, and I want to split this body with this plane. And now we've got a top and a front and a back. So now, just like before, I'll choose Shell, I'll choose these two faces, and make it 2 millimeters thick, and now we've removed all of that material. What I can do now is let's just add a small little feature back here that will actually stop the motor from sliding too far back. So to do that, let's just sketch on this face. I'm going to hide the back. And let's just draw a center rectangle. This is on the inside of the enclosure. It really doesn't have to be a beautiful looking feature. So I'm just going to make this, how about 5 millimeters tall and 10 millimeters wide. And I can now use Extrude to extrude this, and just like before, to this end of the motor. And I want to join it with this body. So to make sure I'm not joining it with the motor, I'm going to hide the motor. And now we've added this little stopper in the back so that when we slot the motor in, it's going to sit nice and tidy right there. Cool, so we've got everything just about done. Let's go ahead and, like last time, combine the front and the back together. So now we just have a top and a bottom to this. And we can now do just a few more things. Right now there's no way that these two parts are actually staying together. So I'm just going to model in 2 pins at the front here that are going to be 3D printed as part of the enclosure and make them a nice tight fit so that this snaps together. So I'm going to create a new sketch on this surface. And let's just draw a line that goes roughly down here. And I want it to be symmetrical and in the middle of these two lines. So I can choose Symmetry. I can pick a couple of lines and pick this one. And now I know it's nice and symmetrical. And let's draw a circle on this line. So let's make that 3 millimeters. And let's just say that it is 3 millimeters away from the end. And now I can use Extrude to create sort of the male part of this pin. And if we want, we can add a little chamfer to the end here so that it sits in the pocket a little bit easier. So let's make a duplicate of that on the other side. So just like before, we're going to choose the mirror command. And I want to mirror this extrude feature and this chamfer feature about this YZ plane. There we go. And now I can make some matching holes on the bottom here. So I'll create another sketch on this surface. And I don't want to just guess at where those pins are located. So what I can do is, just like before, I can project these in. So under Sketch, let's just choose Project, and let's just project in the bottom of these pins into the sketch. That way now when I'm creating these holes, I know exactly where everything's going to line up. So now what I can do is just click Look At to get a nice view. And I'm going to turn these into construction lines by hitting X. And let's just draw some circles for the holes. So this is going to be a little bit larger. I can now use my dimension tool, and I can just say that the distance between them, and really this is the tolerance here between the pin and the hole, let's just make it 0.1 millimeters. It might be too tight to actually fit, but for my printer, I know that that's about the right tolerance I need. So let's go ahead and extrude this down. The pins were 2 millimeters tall, so let's go, how about negative 2.2 millimeters deep? That way I know that this can actually shut. And let's, just like the pins, let's go ahead and mirror that about this midplane. Cool. So now we've got this enclosure that really snaps together. A few more things we need to do is add a little hole here for the wire to come out the back. So let's just draw a hole back here. I'll draw a circle. And it's going to be 4 millimeters. And I want it to be vertically aligned with the middle of this midpoint back here. And let's just say that it sits about 4.5 millimeters above the ground. And sorry if this is fast, I'm just trying to jump through it, and a lot of these steps are pretty repetitive. So now I can extrude this profile to this inner surface. Cool, so now we've got a nice hole where we can feed sort of the snipped wire through here. I then soldered it onto the leads of the motor, and then the top of the housing can snap right on there. I think all that's left for the housing is to just close this off over here if you want. It's really just visual, but we can do that. So I can create a new sketch here. And let's just draw a line. Actually, we can just offset. Let's just draw, let's project it in, sorry. So just like before, I'll project in the motor. And I can use the offset tool to offset it by 0.2 again. And now we can extrude this back. How about just 10 millimeters? And now we've got a nice closed front. So if I hide the motor and this is the part that we're making over here. It looks really printable. And this one over here, it's a nice looking part that I think will print just fine. Cool, so we've got just about everything together. We've got the motor, we've got the housing, and we just need the fan now. So the fan's a little bit more advanced. So what I did is I went ahead and modeled it, and I created a link to it. So the link, if you follow the link, which I'll share in just a second, it'll take you to this viewer right here where you can see the fan blade, and you can click this download button and download the Fusion file, and it's going to need a second to translate, so it'll ask for your email, and it'll send you the Fusion file, and then you can download it to your desktop. So let me go ahead and share this link with you guys in case you want it. So I'll copy this link. And I think in the GoToMeeting I think I can go to the chat. Okay, so I pasted that in to the chat if you guys want to follow it and download this file. Once you've downloaded it, you can go to your project and choose upload and pick the file, and then the fan will show up here in your data panel. So to bring the fan that you've uploaded into your Fusion design, what we need to do is right-click on the fan blade and choose Insert into Current Design. So it's going to grab that fan blade model and drop it into my design over here. If I want to just move it over here to see it, I can do that. And now I've dropped the fan blade into my Fusion design. So it's actually referencing this design right here. So if I make changes to this fan blade, it's going to be reflected in this one over here, which maybe is what I want, maybe it's not what I want. But let's go ahead and apply first a joint to this. And a joint is really a way that you define in Fusion how parts are assembled. So the best way to think about this is think about which parts are not moving first. So which part is grounded. The housing is not going anywhere. So I'm going to start by right-clicking on the housing and choose ground. So now the housing won't move anywhere, but the motor and the fan blade are, can move anywhere. So let's go ahead and apply we can either apply a joint or an as-built joint. We have a bunch of videos online if you want to learn more about assembly, so sorry if this is a little fast. But we can apply an as-built joint, which is really that the two components you want to put together are already in the correct position. They just don't have a joint relationship. So I'll choose as-built joint and say that I want to create a relationship between the motor and the housing, and I want it to be rigidly connected, and now they're stuck together, and it'll animate what that is. So now if I try to move the motor, it won't move anywhere. So now that was as-built joint. The joint command is useful when you have parts that are not in the correct location. So this fan blade, for example, it's not currently where I want it to be. So in this case, I'm going to use the joint command. So I need to choose two things to align. So I'm going to align the end of the motor with the inside of this hole in here. I'm having a hard time picking the end of the hole. When I hover my mouse over here and I see those three options, on Mac I can hold Command, or on Windows I can hold Control. And now I just isolate those three. So let's pick the back of that. And now it puts them together. I actually don't want them to be rigidly connected. I want them to revolve about each other. So I'll hit OK. And now it snaps the motor back there, and the fan can revolve around the shaft. So if I click and drag on the fan, it will show that it can rotate. One thing that I see over here is that the fan's not really sitting as far in as I'd like it to be. So because this fan blade is really, I inserted it into this design, it has this linked icon telling me that it's actually referencing this other Fusion 360 design. So what I can do is I have two options. I can either make a change to this design that's being linked in the other one and have it then show up in the design where it's been inserted, or I can break the link. So if I want to make a change to the model here, I can, let's just say I want to move this in a little bit. I can pick this surface and choose modify and press pull, and let's just move it up 2.5 millimeters, so we have a little bit more room. And I'll choose save, and I could say here moved hole back. And now in the design here, I get a few warnings telling me that that fan blade component's out of date. So I can right click on it and I can choose get latest, and it's going to look at that fan blade design and make any changes to the model here. So now it's gone ahead and even updated the joint, and everything looks nice. If, let's say, I wanted to make a change to this fan blade here, I could also just right click on it and choose break, and now it's no longer going to be looking at that other part and constantly updating it. So I'm going to go ahead and just break that link. That way if I make changes to this design, it doesn't make any changes to the one that I've shared with you guys. So there you have it. I think that's all. I know it was really fast-paced for just about an hour, but as a refresher, we covered basics of solid modeling, so sketching, extruding, how we can use modifiers like drafts and fillets and shells, and to make some of these complicated parts, sometimes you need to split the body in half and shell out part of it and then join it back together at the end. As one little check that we can do now is we can, for one thing, we can use the section analysis tool, and let's just slice it down the middle. So we can see just a section analysis. So it looks good. I can picture the wire coming in here, attaching to the leads. I might need to update this joint so that it actually slides down all the way. I can turn off my section analysis, and the last thing we can do is under inspect. This is always a good thing to do, is check for any interference between the parts. So I'm just going to pick the motor, the fan blade, and all of these components and choose compute. And it's telling me that there's no interference, which is nice. I don't accidentally have the motor sitting in the same place as the enclosure. Everything's nice and tidy. If I check this box and hit compute again, it'll show me any areas where the parts are touching. So I can see this area is where the motor is sitting down on that surface. This back surface is where the motor is getting pushed into. And then my two halves of the enclosure are sitting flush with each other right there. So everything looks perfect to me. If I want to save my files out for printing, I could go to the housing and I can right-click on either of these and choose Save as STL. I actually printed the housing and the fan blade, and it works. It actually puts off quite a bit of air. It's really noisy, so if anyone wants to make this themselves, maybe I would recommend making this hole for the motor, adding a millimeter or two, maybe putting in some soft or rubbery material so that the motor doesn't vibrate in the plastic as much. But other than that, it's a fun little project. There's a lot of options you can do to modify it. You could add a switch to it, some things like that. But hopefully this was a nice introduction to Fusion 360, even if it was a fast little crash course. If you guys have any questions, I think we might have time for questions, but I'm all ears.
Thanks, Taylor.
You're welcome.
All right, I'm getting some questions. I can read them to you.
Cool.
Oh, Pete just said that's a great demo. And guys, I can unmute you also if you want to ask a question, if you raise your hand and you have a question to ask. And also the recording we'll upload this to YouTube hopefully this afternoon. So I can send you the recording so you can do this step by step on your own time. Okay, let's see, Pete. Oh, Pete asks, what do you send to your printer? Is there a special file?
Just an STL file. So because I want to have the top and bottom half print on their own, I'll right-click on each one and choose Save as STL. I'll just make sure that this is at high quality and hit OK. And I'd call this, housing top. Do the same thing for this guy and call it housing bottom. And then I'd take it into whatever slicing software you use. I happen to have a MakerBot, so I use the MakerBot software. And then in here, I'd go ahead and add, those two parts. And I could go ahead and move them around, position them, do whatever I need to do. So if I need to rotate this guy, I can do that. Hopefully that answers it.
I have a question. Can you send directly to a 3D printer from here?
From Fusion or from?
Yeah, from Fusion.
No, because it's going to really just need, you're going to need a slicer somewhere in there. It would be like trying to go from Microsoft Word to your inkjet printer without like any drivers, pretty much.
Right. Any more questions? All right. If nobody has any more questions, I guess we can finish up. And thanks again, Taylor.
Yeah, you're welcome. And if you guys want to stay in touch or have questions, the best place to reach me is probably Twitter. So it's just twitter.com/Taylor_Stein. You can find me there with any questions.
Awesome. And if you're interested, I can add you to our Slack team as well for Hackster Live. There's a lot
Cool.
I think we actually have I'm not sure if we have a 3D printing channel, but if we don't, we should create one. An Autodesk channel, actually. Yeah, cool. Okay.
Cool.
All right. Thanks, guys.
Thanks, everyone.